We are living in an exciting time of human exploration. For the first time since 1972, NASA is sending humans to the moon with mission Artemis. And unlike the Apollo era, Artemis astronauts will work to establish permanent bases on the moon, using the knowledge and experience we gain there to pave the way for the human exploration of Mars. The Artemis program relies on the powerful Space Launch System, or SLS, and the Orion spacecraft, which will transport astronauts to the Deep Space Gateway in lunar orbit. The astronauts will then transfer from this lunar outpost to the Human Landing System, or HLS, which will then deliver them to the surface of the moon. We at the South Texas Astronomical Society have teamed up with NASA for an exciting project called Generation Artemis. Our goal is to connect the Rio Grande Valley community with this incredible endeavor carried out by NASA and their partners like Blue Origin and SpaceX. Last summer, we hosted a series of Artemis summer camps where students learned about each component of the mission through hands-on STEM activities. And now you'll have the chance to do those activities with your explorers as well. Get ready to embark on a journey of discovery with Generation Artemis. Let's ignite the spark of curiosity and explore the future of space together.
In this activity, students will build and launch their own foam model rocket representing the Space Launch System. In the design of the rocket, students will explore how fins affect stability of flying objects, the relation between a rocket's attribute and its trajectory, and how to alter designs based on testing and re-evaluation. For this activity, you will need scissors, 3 zip ties, 1 ruler, 1 square of cardstock, a string measuring 75 centimeters, and 1 piece of foam pipe cut to the length of 30 centimeters. Some prep work from administrators may be done with measuring and cutting the foam and string. Take the foam tubing and cut 7 centimeters long incisions in a cross shape or plus sign formation. With a square cardstock, you want to cut diagonally across, forming 2 triangles. Now cut one triangle halfway down the middle and the other halfway up the middle. Slip the papers together, creating this 3D formation. Take 75 centimeters of the string and fold it down the middle. Tie a knot at the end, forming a circular string shape. Now, align your folded string end and the rubber band and zip tie the two together. Here's where it gets tricky, and it might be a good time to call the adults over. You want to insert the string contraption into the foam tubing, with the rubber band end at the opposite of the incisions. Take a zip tie and cinch the end of the foam tubing with half of the rubber band still exposed. You want to tighten this zip tie really hard. Make sure the rubber band will not leave the grip. Insert the cardstock into the incisions. The knotted end should hang out between the paper and tube. Take your zip tie and secure this end as well. Test your rocket launch mechanism by using a leverage at your rubber band and pulling from the knotted end. It should work similar to a slingshot. An optional challenge step is redesigning your rocket and testing the effects of each modification. Ask yourself, how do the fins affect the flight of the rocket? What about the strength and pull? What about the angle? Keep the fun up and enjoy your mini mega rocket.